They may look like toys, but these small planes flying high above Oklahoma State University in Stillwater may one day help weather forecasters predict storms and save lives. Oklahoma State, along with 4 other universities, won a $6 million National Science Foundation grant to develop small weather-sensing drones. Professor Jamie Jacob is the project's principal investigator.
And the goal of the project is to be able to put in the hands of end users in 4 years, meteorologists and atmospheric physicists, the technology that allow them to perform routine day-to-day measurements of the atmosphere. And that's really there to improve both our understanding of the atmosphere as well as improve our forecasting of severe weather events.
The building obviously takes the longest part.
24-year-old Alyssa Avery is one of Jacob's graduate students. Over the past 2 years, she's been building her own aircraft named Maria.
The project is basically designing an aircraft, a small one, remotely piloted, that can fly around severe storms and collect as much data as we can so we can lengthen that warning time and make it more safe for everyone living in tornado areas.
As an engineer, her job is to build a plane strong enough to fly close to developing supercells, the megastorms that often lead to tornadoes in Oklahoma. Avery's aircraft is designed to deploy sensors that monitor temperature, wind speed, and atmospheric pressure.
We can't measure this stuff from the ground. It's better to do it from in the air.
Right, so right now we have radar, which obviously everyone knows about. So it surveys at a higher altitude, and it did improve weather models a lot. But when it comes to that really precise, like how close is it gonna be, where is it gonna be, what's actually gonna turn into a tornado versus just circulation, which is much less dangerous, they don't have that. It's called in situ, which is right there thermodynamic data.
In other words, forecasters need to get closer to the action, scanning parts of the atmosphere that traditional radar, weather balloons, and sophisticated weather towers can't reach. The sweet spot is called the lower atmospheric boundary layer, a zone roughly 1,000 feet off the ground. Philip Chilson is a professor of meteorology at the University of Oklahoma and is also involved in the project.
There has been a need for high-quality measurements of the lower atmosphere that's been known by the meteorological community for decades. The lowest level of the atmosphere is so dynamic spatially and temporally that it's very undersampled at present.
So to get more information about that part of the atmosphere, students at Oklahoma State aren't just building the planes, they're designing the sensors and writing the software that processes the data gathered in the skies. 21-year-old Nicholas Foster is designing a small pod that aircraft like Maria may one day carry into a storm.
And essentially it's just a packet of sensors.
Okay.
So what I'm doing is these will go inside of Maria, and these will be the things that fall out and they parachute down and take the data on the way down.
The Oklahoma State researchers hope this technology can be used at home and around the world to give forecasters earlier warnings of severe weather.
Getting this data will allow them to take our forecasts, which are now, for severe storms and tornadoes at the 10 to 15 mark, maybe up to the hour mark, where we can actually warn on forecast and be able to say, hey, you're going to have severe weather in your area, and this is the probability that you're actually going to see something like a tornado. And that's really going to save lives in the end.